Okay, so here we will try to understand different pressure terminologies. Okay, so in pressure we have different terms used. Okay, sometimes we use absolute pressure, sometimes use gauge pressure, sometimes use vacuum pressure, but most day-to-day pressures that we refer here is actually the gauge pressure. Okay, so gauge pressure is the one that we are actually referring most of the time. Okay, so for example, if you measure put a air inside the wheels, okay, like vehicle tire, so the whatever pressure that is inside, if you happen to put that pressure measuring system and then see, the needle will move, and as you remove from the tire, and it will go back to zero. Okay, so that zero pressure is actually your atmospheric pressure. Okay, so it is scaled like that. Actually atmospheric pressure is not zero, but it is reference to that of zero. So when you put a pressure inside the car, okay, like car tire, so usually we put like 40 psi. Psi is pounds per square inch. Okay, so that's you can convert this into Newton per meter square or Newton per mm square. So when you put that air pressure inside the tire, what happens is the tire is actually having pressure more than atmospheric pressure now. But you see that this from here, let me go here, this is your atmospheric level here. Okay, also although the pressure here is at the depth is zero, and here it is increasing here. Okay, this is not depth, but just giving you an example here. So, and here maybe the pressure is increasing up. Okay, here, so from here absolute zero pressure, and here this is the atmospheric pressure, that pressure that we are experiencing. Okay, and we don't know, because we do not feel that atmospheric weight on us, because our blood pressure is quite higher than atmospheric here, so that's why we don't feel that. So that's why for our convenient, we put this pressure and atmospheric pressure, this atmospheric pressure as zero. Okay, so whenever we are applying a tire pressure, so it is marked from here. Okay, so when you marked put the pressure, so it is marked. So when you put the pressure, so we measure 40 psi, 33 psi and all. So that pressure that we are measuring is actually the gauge pressure, because that is marked above your atmospheric pressure. Okay, making your atmospheric pressure as the datum. Okay, when you say it's a datum, you are marking at that as zero. So that's why making that atmospheric pressure as zero, as the datum. So from that, so whatever we measure, that pressure is actually the gauge pressure. So that is the most gauge pressure is the most used pressure that in our day-to-day activities. Okay, but sometimes we have to measure, sometimes in calculations we are also asked to measure the absolute pressure. So absolute pressure is if the gauge pressure is 40, okay, psi, that we put in the tire, plus what is the atmospheric pressure, okay, from the air. So that atmospheric pressure is very standard one. So so that, let's say I do not know that what is the atmospheric exact value. So if it say let's 100 psi, so once, and then you calculate this, 140 is actually your absolute pressure. Okay, so that is, you can see here, gauge pressure plus your this value from here to here is your atmospheric pressure. So that, so gauge pressure plus your atmospheric pressure is actually your absolute pressure. Okay, so that is your thing. And there is another vacuum pressure. So vacuum pressure is actually defined as pressure below your atmospheric pressure. So this is if the pressure is below your atmospheric pressure. If the pressure is above, measured above the atmosphere, is gauge. If the pressure is measured below your atmospheric pressure, is known as vacuum pressure. Okay, so that is your vacuum pressure. So mathematically you can see absolute pressure is P absolute is atmospheric plus P gauge pressure, and vacuum pressure is atmospheric minus your absolute pressure. So since absolute pressure is always higher than your atmospheric pressure, so that's why what you'll get is vacuum pressure. Usually you'll get in negative. Okay, so that is these three terminologies. So here you have activity 2. You can, here you are asked to find out the what is the gauge pressure and absolute pressure at a point, okay, at a point 3 meters below. So depth is given, okay, so depth z is given as 3 meters from the surface of the liquid, free surface of the liquid, and this has a density of 1.53 raised to 10 raised to 3. So here basically we can understand that this is not water. Okay, so this liquid is not water because density is quite higher than the density of water. So it is 1.53 times higher. So specific gravity, you can say that, of this liquid is directly, it's a hint here giving you specific gravity of this liquid is 1.53 because it is 1.53 more dense than that of water. Okay, so that's the thing. So if the atmospheric pressure is equivalent to 750 mm Hg, okay, mercury, so atmospheric pressure is also calculated in mm, I told you, right, in terms of meters, millimeters. So that is actually your pressure head. Okay, so this is not the pressure in Newton per meter square, but that is actually a pressure head, 750 Newton, not Newton, mm per Hg. So specific gravity of mercury is given here, and density of water is also given here. So from this one, so we know that the depth, we are asked to find the pressure, gauge pressure and absolute pressure at 3 meters. So Z1 is this one. Density is already given. Atmospheric pressure head, so I told you it's a pressure head, Z0, so it is 750 mm Hg, so you convert in terms of meters, so 0.75 mm Hg. So atmospheric pressure is P is equal to, we already seen, P is equal to rho G into Z, right? So rho G Z, so rho naught G into Z naught, so that is your atmospheric pressure. So here you can see rho density is here, specific gravity times it's then times 1000, so density is here, G is here, and Z naught is here. So atmospheric pressure is 10,000, not 1,62 Newton per meter square. Okay, so that is your pressure, atmospheric pressure. So now once we calculate the atmospheric pressure, because basically your absolute pressure and gauge pressure is with respect to atmospheric pressure, right? So first we always need to calculate the atmospheric pressure. So now once you calculate the atmospheric pressure, so now only you can calculate what is the gauge pressure and your absolute pressure. So now pressure at 3 meter depth, so is, you can also use same formula, rho 1 G1 Z1. So P is equal to rho G Z. So that is the general rule here, rho G into Z or rho G into H. Sometimes some books will refer as rho G into H, sometimes it is rho G into Z. Okay, so that's how we will see. So rho 1 is that of that liquid, okay, and Z1 is the depth of that liquid, and or the pressure at which you are asked to find, and you know that this density is given as 1.53 times 9.8 and the depth is 3. So here you get the pressure at that point. So this is actually your gauge pressure, see. Okay, so this is the gauge pressure. So now you are asked to find out the absolute pressure. So absolute pressure is your gauge pressure plus atmospheric pressure. Atmospheric pressure you already found out, so you get this as your absolute pressure. Okay, so that is how you need to find. But if you just find out the pressure, using nothing, you don't consider anything, atmospheric pressure, so that whatever pressure you directly find out with respect to depth will directly be your gauge pressure. Okay, and then if you add atmospheric pressure on top of gauge pressure, then that will give you the absolute pressure.